Hey everyone, and welcome. Today we're diving into a Leetcode problem called Find Words Containing Character. It sounds pretty straightforward, and our goal is to break it down so it's super clear. Let's get started. So what's the task? We're given a list of strings, which the problem calls, and a single character, called prepimex. Our job is to go through this list of, and for every word, check if our special character is present in it. If it is, we need to note down the position or index of that word in the original list. Finally, we return a new list containing all these indices. The problem also tells us the list of won't be too long, and the words themselves also have a limited length. And the character will always be a lowercase English letter. Okay, let's walk through a quick example to make sure we've got it. Imagine our input list of words has two words in it. First, the word, and second, the word and the character we're looking for is the letter. First, we look at the word. It's at index 0 in our list. Does contain the character? Yes, it does. So 0 is one of our answers, and we'll add it to our result list. Next, we move to the second word, which is at index 1. Does contain the character? Yes, also has an ILI. So we add 1 to our result list as well. We've checked all the words in our input. So our final result is a list containing the indices 0 and 1. Simple enough, right? So how should we tackle this? The most direct way, and often a good starting point, is to simply simulate what the problem asks us to do. We can just look at each word in the input list, one by one. And for each of these words, we'll perform a check. Is our special character located anywhere inside this particular word? If the answer is yes, then we take note of the position, or index, of that word, and save it. Alright, here's how we can write this logic in Python. It might look like a little block of code, but don't worry, we'll break it down step by step so every part is clear. First things first, we need a place to store our answers. So we create an empty list. Let's call this list result indices. This is where we'll collect the indices of all the words that contain our target character. Next, we set up a loop. This loop is designed to go through each word in our input list, which is named, we use a little helper, as a counter. This will keep track of the current position, or index, of the word we're looking at, starting from 0 for the first word, 1 for the second, and so on. Inside the loop, for each value of, we get the actual word from the list at that specific position. We can temporarily store this word in a variable, say current word. Now for the current word that we've just pulled out from our list, we perform the main check. We ask, is our special character present anywhere inside this current word? Python has a really convenient way to do this check directly. If it turns out that is found in the current word, then we take the index. Remember, is the original position of this current word in the input list, and we add this index to our result indices list. After the loop has gone through every single word in the input list, and performed this check for each one, our result indices list will contain all the indices we were looking for. So the very last step is simply to return this result indices list. So let's think about how efficient this solution is. For time, we have to look at every word in the input list. Let's say there are words in total. For each of these words, we then check if the character is inside it. In the worst case, for a very long word, we might have to scan through all of its characters. If the maximum length of any word in our list is characters, then the total time taken will be roughly proportional to multiplied by. In big O notation, we write this as big O of n times m. Now for space, or memory. Besides the list that we eventually return, which contains our answers, our program doesn't use much extra memory. Just a few variables to keep track of things. So if we don't count the space taken by the output list itself, the additional space is very small, what we call big O of 1, or constant space. If we do consider the output list, it could, in the worst case, store indices if every single word contains the character. So to wrap things up, the core idea here was to systematically go through each word in the given list. For every word, we used a straightforward method, often built into the programming language, to search for the specific character. When we found the character in a word, we simply collected that word's index. This problem shows that sometimes, a direct simulation of what's being asked is a perfectly good and efficient approach, especially when the constraints are manageable. Hope that explanation made sense and helped you understand the problem and solution a bit better. If it did, feel free to hit that like button, maybe subscribe for more Leetcode breakdowns, or drop a comment if you have any questions or thoughts. And hey, if you're feeling extra generous, there's always the Boba Fund. Keep practicing, keep coding, and I'll catch you in the next one.